Okay, let me slowly start. So today is the last day of this year, 21, 2021, or 31. So from tomorrow, we'll have the new year. So let's continue with my seminar on mathematics throughout the ages. So today is yes 11 by number. Uh, Today's topic is heritage of geometry. So I'll be talking about how geometry evolved. So I'll start with this uh, majestic historic photo. This is ICM 2002 here in Beijing, in the People's Great Hall. It can accommodate 10,000 people. Okay, me and my wife were present in this inaugural session in the People's Great Hall, where this Chinese Communist Party's meetings takes place. Our focus is this banner over here, this one. So today, this is the banner we'll start talking about. So now, this is from the conference, Beijing ICM 2002. This is the booklet we were given, the Congress of Mathematicians, ICM 2002. So this is over here. On left, you can see the same one with Chinese indication. So the ICM 2002 was taken from, this logo was taken from the book on numbers and computation of the writings on reckoning. It is one of the oldest known Chinese mathematical treatises, this book, which I have translated, book on numbers and computation, or is also sometimes known as writing on reckoning. So I have taken this from that page. I will show more of this book over here. So we'll be first of all start with this logo. Anybody know what is this logo? What does this represent? So mathematically it is here with Chinese characters. But do you know what is this one? Anybody has an idea? No. So from the inside page, the Chinese from the text over here, it looks like this. Now, if you look here, you can see what is here. A square plus b square is c. So this is the mathematical or geometrical representation of the Pythagoras theorem. So it is the proof of the Pythagoras formula written in Chinese over here. So that is why this ICM 2.2 logo was designed in this way. So if you go inside, there are certain books known as, there are a lot of books on historical books written in China. This is an illustration of a Chinese dissection of the Gongdu rule, that is Pythagorean theorem, from the Ruby Sunjiang, or arithmetical classic of the Gnomon and the sulfur parts of heaven, a book on astronomy and mathematics, dated to approximately 1000 before Christ. This image is from a copy I printed it, which was printed in 16. There is a copy printed in 1603. So I have taken the source from this mathematical treatise, Ruby Sunjiang, which I found in the Mathematical Association of America Convergence series over here. Nowadays, due to pandemic, I am receiving a lot of this type of convergence from Mathematical Association of America. I am a member of it, and so I was lucky to have this one page over here. It's a 400 plus year book. So you can see immediately after the opening, the People's Great Hall, then in the adjoining dining hall, which can accommodate 6,000 people at one time, we had a launch after the opening over here. Minister of Education was present over there. Anyway, so you can see me and my wife and the delegates attending this ISM 2002, which was there in Beijing from August 18, September 1, 2002. Now, to our topic of geometry. Of course, everybody know what is geometry. So, the high school conception of geometry is that it is the study of shapes such as circles, triangles, cubes, and spheres, together with concepts such as rotation, reflection, symmetry, and so on. So the object of geometry and the process that they undergo have a much more visual character than the equation of algebra. So that's why people love working on geometry, because it's visual, and once it is visual, then it attracts many people, including our students. So I have here the cover page of Euclidean geometry. So it is understood that it is the Euclid who started the geometry concept over here. So it is the page from Euclidean geometry written by Euclid himself long time back. There are a lot of old books over here which we can scan and see. So the first 6 books of the elements of Euclid was published in London in 1847. So then there is the Sacred History of Pythagoras, translated from the original copy. So it was in 1751. It is still printed in London, still World War I, 1751. So I have a collection of such type of work. Now, since we treat Euclid as the mathematical founder of elements of geometry, we just start with this treatment, elements of geometry. This element is by far the most famous mathematical work of classical antiquity, and also has a distinction of being the world's oldest continuously used mathematical textbook. That's why there are so many versions over here, which I have shown. It is known about the author. It is known about Euclid himself, beyond the fact that he lived in Alexandria around somewhere in 3000 before Christ. Most of the terms appearing in the elements were not discovered by Euclid himself, but were the works of earlier Greek mathematicians such as Pythagoras. That was described was actually done by Pythagoras, and Hippocrates of Chios, Theos of Athens, and Eudoxius of Cnidos. So there were earlier mathematicians before Euclid who had worked on geometry, but they were not, they were isolated type of working, and only Euclid has put in a systematic, asymmetric way. However, Euclid is generally credited with arranging these theorems in a logical manner so as to demonstrate, admittedly, not always with the rigor demanded by modern mathematicians, just like a proof is not like that they necessarily grow from 5 simple axioms. So his geometry, his elements of geometry, is based on these 5 simple axioms. The elements consist of 13 books. These elements consist of 13 books. Book 1 outlines the fundamental proposition of plane geometry, including 3 cases in which triangles are congruent, various terms involving parallel lines, the theorem regarding the sum of the angles in a triangle, and the Pythagorean theorem itself. So I have taken a book translated in English from the original Greek over here. On the left, you say the Greek is here, and on the right is its definition. So from the book 1, elements book 1, start with the point is that obviously there is no part, and a line is a length without breadth, and the extremities of a line are points. A straight line is anyone which lies evenly with points itself, and so on. So this is all in the book of elements by Euclid is written in Greek in this way. And now we have English translation, parallel English translation. Book 2 is commonly used, is said to deal with geometric algebra, since most of the theorems contained within it have simple algebraic interpretation. Book 3 investigates circles and their properties and includes theorems on tangents and inscribed angles. Book 4 is concerned with regular polygon inscribed in and circumstance around circles. Book 5 develops the arithmetic theory of proportion. Book 6 applies the theory of proportion to plane geometry and contains theorem on similar figures. similar figures. And book 7 deals with elementary number theory, for example, prime numbers, their common denominator, and so on. Book 8 is concerned with geometrical series. Book 9 contains various applications of results in the previous two books, that is 7 and 8, and includes theorem on the infinitude of prime numbers as well as the sum of geometrical series. Book 12 calculates the relative volumes of cone, pyramid, cylinders, and spheres using the methods of exhaustion. Finally, book 3 investigates the 5 so-called Platonic solids. So, it is elements of geometry contains 13 books and deals on these topics as described. Book 10 attempts to classify and making a bit explanation of this. Attempts to classify incommensurable, that is irrational magnitude using the so-called method of exhaustion. So that word has come, so that is, I have to explain it. An ancient precursor to integration. Book 11 deals with the fundamental proportion of three-dimensional geometry. Book 12 calculates the relative volumes of cone, pyramids, cylinders, and so on. Eclipse is based on the following 5 postulates. So we all already know these 5 postulates. Let me enumerate it. Postulate 1: to draw a straight line from any point to any point. Very simple. This postulate simple says that if you have any 2 points A and B, then you can connect them with a straight line. Postulate 1. Postulate 2 is a finite straight line continuously in a straight line. It tells us that we can always make a line segment longer. That means that we never run out of space, that is, space is infinite. Postulate 3: to describe a circle with any center and distance. It allows for the existence of a circle of any size and center, say center A and radius AB. Postulate 4: that all right angles are equal to one another. It just says that whenever we create a right angle by erecting perpendiculars, the angles created are always the same. It's the right angle. And very controversial, the 5th postulate. Postulate 5: that if a straight line falling on 2 straight lines make the interior angle on the same side less than 2 right angles, the 2 straight lines, if produced indefinitely, meet that on that side on which are angles less than the 2 right angles. This is postulate 5, also known as parallel postulate. So the 5th postulate, I can demonstrate it. It looks like this. You see, if you produce it, it meets somewhere. So then it must meet somewhere. So this is the 5th postulate. The 5th postulate, from antiquity, there has been discomfort with this 5th postulate. The obvious remedy was to find a way to deduce the 5th postulate from the other previous 4 postulates. Many tried. The famous astronomer Ptolemy of the 1st century tried. The great magnificent John Wallis tried in the 17th century. But the most famous of all attempts was published by Girolamo Saccheri in 1733. Yet even this massive work did not achieve its goal. So the effort is still continued even these days. So this is the book by Girolamo Saccheri over here, and it's actually in Italian, so it's Girolamo Saccheri. In English, they know that Girolamo Saccheri. So this was a book where a lot of efforts were done to about this 5th postulate. Now, it started everything, but it's a bit not complete one. So then came the geometry of René Descartes. There is a front piece of 1659 Latin version of Descartes' geometry, showing a portrait of this author. That's René Descartes. In my collection, I have a lot of these such type of front pages of old books. This is another one. This title of one Saturns, the 1659 Latin edition of Descartes' geometry in 1649, and then Franz van Stuyten, 1615, 1616. A Dutch mathematician published a Latin translation of Descartes' geometry, adding his own clarifying explanation and commentaries. So this is that book over here. Polimon de Dione, 1692, contributed an introduction to this book by Van Stuyten. This is covered and title page of elements of geometry, book 1, from the collection of Dr. Seed. Pass over here, it is book 1. After there are 13 books. Book 1, book 2, book 13. I have already shown over here this page of Oliver Viennese, the first 6 books of the elements of Euclid, in which color diagram and symbols are used instead of letters for the greater ease of the learners. This is first time in London, 1847. The cover are also used to make it more illustrative. And this another one, geometry, and also including trigonometry. John Leslie, 1766, 1822, was a Scottish mathematician, and he was also a physicist. Leslie wrote several textbooks, including elements of geometry, and geometrical analysis, and trigonometry. I don't have that cover of that too, or figure of that. The images viewed here are from the 1817 edition of this book. And that geometrical analysis was removed from this title. There is no, in this title, there is no geometrical analysis, which was there in the original. Was removed from the title in the third and subsequent editions. So in the first 2 editions, it was elements of geometry and geometrical analysis and plane trigonometry. Plane trigonometry is still there, but the geometrical analysis has been discontinued from the title. The title is from the third edition of this book. The title page is signed by a previous owner of the book. Here you can see signed. It is his signature of Florian Kajori, 1859, 1930. This is the book. Here this owner, Florian Kajori, used at the time, somewhere in maybe 1890 or something like that. Now, coming back to Chinese, this is the portrait of the mathematician, the first translation of Euclid's elements into Chinese. Dickey and Xu undertook the translation and transcription of only the first six books of Euclid's elements. There are 13 of that, only the first 6 books. Only the first, even in the previous one also, you can see the first book, 6 books looks to be more interesting. Their work, Yong Rong Yori, that is Treatise on Geometry, was published in Beijing. So it was published in Beijing in 1614. The images shown below are from the 1847 edition of this book. Now, still continues. So I have put the title as Mathematical Treasure. It's a treasure over here, which in some way we have access to it. Ignatius Paradise, 1637, was a Jewish philosopher and mathematician. In 1671, he published his own tract of the subject, Elements in Geometry. This text was frequently reprinted and translated into other languages, including Dutch in 1690 and in Latin in 1693. The English publisher John Harris translated Paradise Elements into English and appended his own tract on trigonometry, releasing the resulting book as short but plain elements of geometry and plain trigonometry. You can see here, short but plain elements of geometry and plain trigonometry. 1710 publication. More mathematical treasure. So this is John Playfair, 1748-1819, a mathematician and professor at the University of Edinburgh, British, was known as an excellent teacher. His concern with mathematics learning extended to his writing. Playfair published his Elements of Geometry in 1795, with the idea of making Euclid's elements more user-friendly, and indeed it helped before the teaching of geometry in Great Britain. So Playfair's axioms, he added one axiom: given a line and a point not on the line, it is possible to draw exactly one line through the point parallel to the given line. Now, our more interest is, rather than those historical, that was historically, we need to mention it. But now, more interest will be now non-Euclidean geometry. So I'll talk a bit on this non-Euclidean geometry. The fame for discovering the non-Euclidean geometry goes to two people. Lobachevsky, 1792-1856 in Russia, and Bolyai, 1802-1860 in Hungary, who independently gave similar accounts of this non-Euclidean geometry. So now we'll briefly talk about the life and work of these two mathematicians who contributed in the discovering of non-Euclidean geometry, Lobachevsky and Bolyai. I will start with my Russian friend. Both men described a system of geometry that differed from Euclid, but has an equally good claim to be the geometry of space. So now the remaining focus will be on this non-Euclidean geometry, because other part of Euclidean geometry given by Euclid is well versed by all the mathematicians. Even from the school level, we have learned about it. So, brief life history of Nikolai Ivanovich Lobachevsky, we generally call it Lobachevsky, who discovered the non-Euclidean geometry, developed the non-Euclidean geometry. So this Nikolai Ivanovich Lobachevsky, he was in 1719 to 1856. I have taken the coming slides, I'm drawing slides, from the encyclopedia, mathematical encyclopedia in Russian, which is in my library. So that I'll show you later on. So in the third volume of this mathematical encyclopedia, where start from KOO to OD, so Kovalevsky will come some side inside it, and here it is the place where Kovalevsky geometry or non-Euclidean geometry starts over here, or it's known as Kovalevsky geometry. So I have taken from there. So I also have another book by Lobachevsky himself, which is this book on the Kazan University. I'll talk about this in the coming slides over here. This is the portrait of Lobachevsky, and his own handwriting over here, note here, is a note on different aspects of mathematics. This is his handwriting, you can see. His own handwriting. So I've taken from that book over here. And this is his portrait, because they didn't have photo. It was a last portrait. Here it is in Russian. Last portrait of Lobachevsky, shown from a photograph of 1855. It's in the archive of Academy of Science, Russia, USSR. Now he's alive. He was born on January 1, 1790, at Nizhny Novgorod Oblast, Russia. Nizhny means south of Russia, in the Novgorod region. Nikolai Lobachevsky was born on January 1. So very January 1, born 1, January 1. Birth on January 1 is very nice, I think. It will be tomorrow, January 1. but it was 2022, but it was 1792. His father was Ivan Maximovich Wojciechowski. His father a clerk in a line surveying office, and his father died when Wojciechowski was just 9 years old. His mother was Praskovia Alexandrovna Wojciechowska. He was from Kazan. Nikolai was second of the three boys over here. They have three sons, and he was the middle one. His mother moved further east to the city of Kazan, one another in the south, but he moved further to the east to the city of Kazan, which is closer to Lomacevsky's mother's family, because the father has died. Here in Kazan, she was able to put her son, all the three sons, in a special gymnasium. The gymnasium is just like a kindergarten, which prepares students to enter the Moscow University. And getting admission in Moscow University was very, very tough. And it's a very competitive entrance examination there. All three boys were very bright and liked to study. Nikolai soon discovered a particular gift for mathematics. So, Lomacevsky, he was simply called Nikolai at the time. His mother, his math teacher, who at the time was one of the best in that gymnasium, singled out Nikolai and paid him extra attention in class. In 1805, a new university was found in Kazan itself, in the city of Kazan. It needed new students, and the gymnasium was full of potential academicians. The university offered new students free scholarship. It could have come to a better time for Lomacevsky, who was still struggling to make ends meet because they were economically not in an advantageous position. In February 1807, at the age of 14, Lomacevsky enrolled in university. You can just imagine going to a university at the age of 14. I'm the SLC pass गरेको हुँदैन. म चाहिँ 7-4 सालमा एसएलसी पास गरेको मान्छे म. तपाईँहरू त होइन होला. So at the age of 14, Lomacevsky enrolled in university. So was a brilliant student. At Kazan University, Lomacevsky was influenced by German professor Johann Christian Martin Bartels, a former teacher and friend of German mathematician Carl Friedrich Gauss. So we also all know this Gauss, and so Lomacevsky was enrolled at the age of 14 at Kazan University. Bartels, Germany, also noticed the talented young man. He tutored Lomacevsky 4 extra hours a week at home. Nikolai helped Bartels with students who had difficulties in class, and this Lomacevsky, so they called Nikolai at his younger time. So he helped Professor Bartels with students had difficulty in classes. He was helping the professor himself to other students. So Bartels' efforts paid off in full. Lomacevsky adored him as a professor and became an excellent mathematician. Therefore, Lomacevsky became a professor. Lomacevsky received a master's degree in physics and mathematics, double degree, physics and mathematics, on 3rd August 1811. In 1814, after 1 year, he became a lecturer at Kazan University in the same university. On 7th July 1816, after 2 years, he was promoted to associate professor, so quickly rising up. In 1820, at the age of 30, he became a full professor, teaching mathematics, physics, and astronomy. So he was teaching these 3 subjects: mathematics, physics, and astronomy. He has a dual degree in mathematics and physics. This marked the beginning of his 30 years career at the Kazan University. He served in many administrative positions also in the Kazan University. On 19 November 1850, at the age of 28, he was appointed to the post of Dean of Physico-Mathematics faculty. Kazan University, he served in his post only for 1.5 years. He didn't serve for a long time because after that he served as administration of the university life. So he moved to the the university library. On 30 July 1928, 35 years old, he was elected rector of the Kazan University. Just imagine, at the age of 35, the rector of the university is just like president of a university in American system and vice chancellor in our this Nepal system. He brought a much longed for revival. He reorganized the staff, built new laboratories and observatories, launched the printing of the local newspaper called Kazansky, the Kazan Messenger. The University of Kazan became a major education and research hub for the entire Volga region. He showed his ability in handling the most extreme situation. I'll talk about this extreme situation, some of the extreme situations very soon. So this is the Kazan University building, which was remodeled during Lobachevsky time. Now, a small break from the life of Lobachevsky because I have to show a photo here. A photo of my PhD supervisor, Bollywood. So I took on 5th July 1998 in Moscow, but the photo I have in hand hasn't. So his name was Abdul Qadir Saplis Ghalibulin. This Abdul Qadir, my PhD supervisor. I'm talking about my PhD supervisor. Abdul Qadir Saplis Ghalibulin. He was born on 26 November 1919 in Kazan. In 1938, started study in the mathematics department of physical mathematics faculty at Kazan University. In 1946, after World War II, started to work at Kazan Aviation Institute because he was in this Department of Physical Mathematics faculty at Kazan University. When the Second World War started, he was assigned to aviation. He became actually aviation engineer. So he started to work at Kazan Aviation Institute, now called Kazan National Research Technical University, named after A.N. Tupolev. Tupolev, maybe you have heard it or not. Tupolev is a very nice airplane known after Tupolev, and also a lot of helicopters named after Tupolev. Some of them has come to Nepal also, these helicopters. This Ghalibulin obtained PhD degree in 1950 and received DSc, that is in technical science, degree in 1958 from the same institute, Aviation Institute. Started working as professor in the same institute from 1958. In 1960, People's French University was established in Moscow to prepare highly qualified manpower for different countries. So Ghalibulin was invited as the first dean of the Faculty of Physical, Mathematical and Natural Sciences. From 1964, he created the Department of Theoretical Mechanics in the same university and headed till 1988 until the time of his retirement. He continued to be attached to the department as the professor emeritus. So Ghalibulin supervised the research work of the 30 PhD candidates. I am one of them, 30, and 9 of them obtained DSc degree after getting the PhD degree from Ghalibulin. He has published 8 books and more than 90 scientific articles. He created the School of Inverse Problem of Dynamics. That is a topic on which I have done my PhD under his supervision. S. Ghalibulin died on 17 April 1999 after a tragedy. He was coming back after shopping in the morning, bringing some bread and something. He is back. He was just reaching his home with a car bashed him, and he was instantly killed over here on 17 April 1998. I had a plan to invite him in 2000 because a book which was jointly published by jointly with Ghalibulin by me was released here on March 2020 in this Virendra Sabagriha. So I was invited him, but unfortunately he died in 1999. Coming back to Lobachevsky. During the time of Lobachevsky's term, 2 disasters hit the university. A cholera epidemic in 1830 and a big fire in 1842. So, you can see the hard time Lobachevsky was rector at the time. He was able to keep the damage to a minimum and even received a special message of thanks from the Emperor Nicholas I, Emperor of Russia. Novoseletsky was so popular, he was re-elected rector 6 consecutive times until 14 August 1946, a total of 15 years. He served in his cousin university for 15 years. Imagine. Last days, when Novoseletsky reached his 40s, he finally decided he should have some time for himself. He married a woman much younger than himself, the daughter of a rich landowner, Varvara Moiseva. Novoseletsky had 7 children, according to some sources. That number is actually as high as 15 or 18, but 7 of their children have survived. 1946, Novoseletsky's last term as rector came to an end. Officially, the reason he was made to leave was his poor health. However, more correctly, politics affected the decision. At the same time, his eldest son, a university student, who bore a stunning resemblance to young Novoseletsky and his father's wife and wife, died unexpectedly. So he was in shock and his health deteriorated. It was a tremendous blow to Novoseletsky, who had already lost one son. A few years later, his wife's brother gambled away his family's money, so money was lost, which forced Novoseletsky to sell the family property to cover his brother-in-law's debts. This was a great stress for the grief-stricken Novoseletsky. His health deteriorated further and he began to lose his eyesight. The last decade of his life was a mere shadow of the year past. Deprived of many motivations, Novoseletsky was withering away, virtually becoming blind. Novoseletsky died blind and poor at the age of 63 on 24 February 1856. So, though he served in university as a lecturer for 15 years, so at the end, you can imagine that he died blind and poor. This is the cemetery, grave of Novoseletsky at Art Square Cemetery in Kazan. Now, that was his life history, brief life. Now, we have to go to his contribution. Teaching at Kazan University in the academic year 1914-1955 and 1956 in 2 years. Novoseletsky taught for the first time at Kazan University. He taught courses on theory of numbers according to the course. In the academic year 1816-17, he taught courses on algebra, geometry, and trigonometry. You can see that this type of people, they don't stick to one topic only. Now, कहिले आजकलमा चाहिँ नि अप्टिक्सको टिचर के भनेर चलाउँछ नि नो in such universities is good professors. They teach various subjects in the various types. So he started with numbers, theory of numbers, then went to algebra, geometry, and trigonometry. During this time, his attention was drawn to axiom of parallel postulate. Years 1917-1919, Novoseletsky taught courses on differential and integral equation, integral calculus. I have written something like 1915, 1916, something like, because academic courses, academic session starts in September and then goes up to July, June, last of June. July and August are generally known as the summer vacation. In the academic year 1819, he was made a member of academic council. During 1819 and 1819, he did not teach any academic courses for 2 years. During the 2 consecutive academic years, 1819, 1820, and 1820, 1820, did not teach mathematics. Instead, he taught courses on physics and astronomy. He didn't stay idle. He was teaching physics and astronomy. He continued teaching mathematics in the academic year 1821, 1822. From 1822 to 1825, he served as a member of the construction committee of the reconstruction of Kazan University. You can see that he was damaged by the fire, and so this new building which I have shown picture is actually his contribution, reconstruction of the Kazan University. So now we'll talk about economic geometry. Novoseletsky in 1830 wrote 2 major works. These major works on the geometry different in only one aspect from Euclidean geometry. He called it imaginary geometry, and it is known today as non-equivalent geometry. Lobachevsky parallel postulates. Parallel postulate is a bit different from Euclid's postulate. There exist two lines parallel to a given line. So there exist two lines parallel to a given line to a given point, not on the line. So the point should be outside the line. There exist two lines parallel to a given line to a given point, not on the line. So that is parallel postulate. Lobachevsky published geometrical investigation on the theory of parallels in 1840, which in its 61 pages gives the clearest account of his work. So this is voluminous work, 61 pages. Lobachevsky's 1840 booklet explains clearly how his non-Euclidean geometry works. Paragraph from this. All straight lines which in a plane go out from a point can, with reference to a given straight line in the same plane, be divided into two classes, into cutting and non-cutting. Boundary lines of one and other class of these lines will be called parallel to the given line. Here in Lobachevsky, this is a drawing. This is a drawing he has actually given over. This is from his book. So his parallel concept of parallel is quite different from the Euclidean parallel. Lobachevsky went on to develop many trigonometric identities for triangles, which he held in his geometry, showing that as triangles become small, the identities tends to the usual trigonometric identities, just like here. So in Euclidean, we have sum of three angles is equal to 180. In Lobachevsky, it is greater than, it is less than 180. It looks something like this. And there is another one which is called Riemannian, now it is called, where the sum of the angles is greater than 180. In fact, Euclidean geometry is the only geometry where two triangles can be similar but not congruent. So in normal Euclidean geometry, if triangles can be similar, they will be congruent. But in Euclidean geometry, it is the only geometry where two triangles can be similar but not congruent. That's quite surprising. Upon first glance, the sides do not look straight. You can see it doesn't look straight, but they are for their own surface of that geometry. So it's quite a different type of geometry. Euclidean geometry, it is exactly pi. Lobachevsky geometry is greater than pi. Riemannian geometry is less than pi. And the Pythagorean theorems in this three type of geometry, in Euclidean geometry, c square will be a square plus b square. In Lobachevsky, c square will be greater than a square plus b square. And in Riemannian geometry, c square will be a square plus b square. Now, coming to the last, this is a commemoration of Lobachevsky commemorative plate at Kazan University building. That is from 1827 to 1846. He served as rector of Kazan University. Nikolaevich Lobachevsky is a commemorative point to celebrate 200 years in 1922. And there is some process stand in his memorial here. And there is a buste statue of Lobachevsky created in front of Kazan University on 1st September 1896. Now, I am told there are two persons who could contribute to the creation of non-Euclidean geometry. So one is Lobachevsky, the other is Juan, also known as Johannes Boliani, 1812 or 1861. So about this mathematician, I think most of you have not heard about his name. Boliani was born in Kolosvar, Hungary, now called it's called Cluj-Napoca, Romania. It's a city in Romania. He was born on December 15, 1802. His father, Farag, also called Ufang, was a mathematician. This is all Hungarians one, was a mathematician and a lifelong friend of Carl Friedrich Gauss. Lobachevsky was also in some way related with Gauss. By the time he was 13 years old, Johannes Boliani had been taught geometry and calculus by his father. After 13 years, he was taking lessons from his father. Now you can see photo here, photo taken on 8th July 2018 when we were attending IMO 2018 in Romania, in Cluj-Napoca. So this is the city of Napoca these days. So here you can see my wife here, me here, and my son. Coincidentally, my son Daniel, he was on deputation from Kathmandu University to another city, not Cluj-Napoca, another city in Romania. He was for 2 months as the visiting faculty from Kathmandu University to Romania. He was actually an instructor there for technical college, one of technical colleges in Romania. And so this is Cluj-Napoca, very nice city, very disciplined city, so clean and well arranged city. Now coming back to the life of Bolyai. Bolyai continued his education at the Royal Engineering College in Vienna from 1880 to 1822 and served as an officer in the engineering corps of the Austrian army. Father Bolyai, inspired by his experience of tutoring his son, published his principal work and attempt to introduce studious young to the elements of pure mathematics. In 1832, Bolyai published his account in 1831 in an appendix to a two-volume work on geometry by his father. The first book was written by his father. Bolyai and his father sent their work to Gauss, who replied in 1832 that he could not praise the work. For to do so would be a praise myself, adding, for extra measures, a simpler proof of one of Janus Bolyai's opening remarks. He said, as Gauss has said, nevertheless delighted that he was the son of his old friend who had taken precedence over him. Bolyai was enraged and refused to publish again, thus depriving himself of the opportunity to establish his priority over Gauss by publishing his work as an article in a mathematical journal. Oddly, there is no evidence that Gauss knew the details of the young Hungarian's work in advance. More likely, he saw at once how the theory could go once he appreciated the opening of Bolyai's account. By 1830, Gauss was convinced of the possibility that physical space might be described by non-Euclidean geometry. When Gauss died in 1855, an immense amount of unpublished mathematics was found among his papers. Among it was evidence of his support for Bolyai and Lobachevsky, and his corresponding endorsing the possible validity of non-Euclidean geometry. So Gauss worked on these elements, but he didn't really work on finding the non-Euclidean geometry. In 1854, Riemann was called to defend his habilitation thesis, the postdoctoral qualification that was a German mathematician licensed to teach in the university. So if you want to teach, become a teacher, or just any teacher in German university, you have to have this. After the doctorate, you have to write the habilitation thesis written over here. If it's approved, then you have a license to teach in the German university. As was the custom, he offered 3 titles, and Gauss, who was his examiner, chose the one even least expected on the hypothesis that lie at the foundation of geometry. The paper, which was to be published only after his death, posthumously in 1867, was nothing less than a complete reformation of geometry. So Riemann proposed that geometry was a study of what he called manifolds. These are spaces of points together with notation of distance that look like Euclidean distance on small scales, but which could be quite different at larger scale. Gauss was accurate with Lobachevsky as well as Bolyai, but not more. Okay, this is the portrait of Louis Bolyai, who died on January 27, 1986. It's in Maros Vasile, Hungary, now called Târgu Mureș in Romania. Earlier it was Hungary, now this city has gone to Romania now. Okay. So these are the 2 mathematicians who actually started non-Euclidean geometry. There are a lot of other mathematicians also walk through, just like Riemann I have told, I am not talking about this time over here. And in due time, many types of geometry has emerged. You know, some of them are affine geometry, topology, spherical geometry, hyperbolic geometry, projective geometry, Lorentz geometry, manifolds and differential geometry, and recently, since the information technology has come over here, so there is a new term also known as information geometry. I have found this term information geometry very recently, so I have put it in blue color, different from the black colors I use for other type of geometry. But we'll not discuss all this type of geometry over here, but I will just, the word which is not there in that list is incidence geometry. Because I want to introduce something which you have never heard maybe. And incidence geometry is one of the most basic type of geometries, and most geometries studied are incidence geometries. So it's a summary in some way. Euclidean geometry, which is studied in most secondary school program, is an incidence geometry. When considering other geometries, the following parallel properties are sometimes included in their definition. E1. The Euclidean property states that for every line L and every point P not incident on line, there exists a unique line P through P such that L will be parallel with M. So this is parallel property. If you are here, you will have a parallel line. If you are here, you will have a parallel line. So this is mostly one. The elliptic property says that for every line L and every point P not included to L, there does not exist a line M through P so that L will be parallel to M. So there are no parallel lines. So we are talking of incidence geometry. The third one, the hyperbolic property states that for every line L and every point P not incident to L, there exists more than one line through P that is parallel to line. And then I have quickly put here some 3, 4 slides to describe some of them only. Affine geometry. And affine geometry is an incidence geometry. I started the incidence geometry, that's why I have to include here. And affine geometry is an incidence geometry where for every line and every point not incident to it, there is a unique line parallel to the given line. Affine geometry is a generalization of the Euclidean geometry studied in our high school. Okay, that is. So I don't describe all the new geometries which has come into life in the recent years. So in my library, I have some books on geometry which I like to show here. So first of all, this one. Here on the last row in my library, this one of the back of the library. These are the encyclopedia. So of course, they are in Russian, and there are some books. These are dictionaries over here. There are some. Here. So you can see that I have a lot of from the encyclopedia. I can make a lot of references here. This one is lying here is the our KU publication. I am one of the author of this book. Is the our making of Kathmandu University, that is physical development of Kathmandu University in 2 volumes. Now I am working on the third and fourth book of this, the second part of this one. Here we have description of the construction of physical construction of Kathmandu University of 2006. Now I am working from 2006 onwards to the 2021 over here. It takes some time to make that. Anyway, that is some information. Now, the book I have here, one book I have shown earlier also when I was doing Algebra. I have shown this book. This is the manual for teaching algebra and geometry in school. I have talked about algebra. Now, it also has a geometry for school. This is a collection of articles written by experienced teachers and pedagogical experts. And I have one other now, very new book, geometry, something like this. You can imagine that this geometry is for class level. So I wrote this book. It's a geometry textbook for class 11, not ordinarily normal high school class 11. It's only for those schools where they teach mathematics with in-depth study of mathematics. They are in Russia, in Soviet Union earlier, and in Russia, they are specialized school with emphasis or with in-depth study of mathematics. So this is textbook for that type of people. Similar textbook, similar book for class 10 is also available. I don't have in my collection. It was not available at that time. I could only buy the class 1. Methodological recommendations for teachers are also available for this class 10 and 11 textbook, which is in-depth study of mathematics. Then I have this another book written in Russian, but it's a translation book. It's a geometry in the popular series of known mathematics written by Gustave Jouvet, a French professor. It was translated from Russian by mathematician Bhadra Man Tuladhar. In this book, an axiomatization will be found which bases geometry on the concept of parallelism, perpendicularity, and distance in a manner that rapidly, naturally, easily brings out the algebraic structure of the and space. Then I have another book over here. So it's called Visual Topology. It's not topology, it's called Visual Topology. It's written by two mathematicians, Vladimir Grigorovich Boltiansky and Vladimir Alexandrovich Efimov. It's more on topology. There are some type of elementary books. I don't have in my collection standard textbook, university textbook, because when we study Russia, Moscow or in Russia, at a time, at the start of the academic semester, everyone gets a full set of the textbook needed for that semester. You don't have to buy any book, textbook. The textbook is given by the library, full volume, full packet of for the whole semester is given by the university library, which you have written after the semester over here. So I don't have any textbook as it is. I generally buy all books. Now, lastly, this is a very recent one, published in 2009 only. With this cover page over here, I will try to translate it. It's called Visual. No, it's not visual topology. It's a basic for Finster geometry. माथिको visual topology मैले त्यहाँबाट copy गरेर चुकेर आएँ. The translation of this book is Nachala Filarsky geometry and it's the basic of Finster geometry for physics. I think most of you have not heard this word, Finster geometry. It is very needed geometry for physics people. It was written by G.I. Carrasco, and it was presented to me in Moscow on 4 February 2000. The book was actually published in 2009 only. So the book was presented to me by Professor Gladys Jev, Bauman State Political University, Moscow. He actually invited me in 2009 with regards to the discovery of gravitational waves in 2009. So the discovery of this gravitational waves, which was 100 years, almost 100 or 150 years theory given by Einstein almost 100 years back, was discovered only on January 2009. So there was a conference related to this discovery at the Bauman State Political University, and I was invited to participate in that international conference. Physics, as a part of physics, on the discovery of Albert Einstein gravitational wave. Okay, so that will be enough for today, because most of you have to celebrate, some of you may be celebrating this Happy New Year 2020. So then, my Happy New Year, congratulations to all those who will be celebrating 2022. But for us, the next year, 2022, will be present here. I hope so. And so I wish everybody a very nice coming year 2022. Because after few months, I'll also have our Nepali visa Nasi coming. Okay, that's enough for today. Okay, and so I have written here January 7, 2022. Now there will be a break. So this is not correct because it was planned all year. It is not correct now. Our next seminar will not be on January. Here we'll have a 1 month break. We will take a 1 month winter vacation break, and we'll have the next seminar on February 11 only. We'll again put a notice. We'll have our next here on February 11, Friday, 2010. We'll have a 1 month break over here, and I'll be talking on the same topic. It is seminar 12. I'll be talking about Carl Friedrich Gauss, because in this seminar I have at many places we have the name of Gauss, so that is why I thought that is now required to talk about this Carl Friedrich Gauss, very different type of mathematician, and now we'll have to move to other topics also. That's why we start with the next mathematician, George Cantor, so that then I can move on to Saturn. Yeah. So that's why next time it's not January 7, so it will be February 11, 2022. So you will have a notice in the Facebook very soon. And so we'll be talking about Carl Friedrich Gauss and George Cantor. So that will be, and Happy New Year to all of you. Okay. Okay. Going back.
Okay. सक्यो होइन सर?
कति भन्ने आज बिहान फेरि मेरो अर्को क्लास पनि थियो आज बिहान 1 बजेदेखि थियो.
Okay. I think so geometry is one of the very important branch of mathematics, and I really enjoyed the actually the whole session of Bhadra Man sir. त्यसको development चाहिँ from the very beginning of from the very ancient age to the modern and present age सम्मको development like सरस्वती travel गर्न पाउँदा it was really a wonderful journey for me. सर म्यामहरूसँग केही क्वेसन छ केही क्वेरी छ भने सो यु क्यान आस्क भद्रमान सर.
मैले हिस्ट्री पढाउने हो कि अहिलेको नयाँ डेभलपमेन्ट हामीले धेरैले जानेको होला, हेर्न सकिन्छ. त्यति पुरानो हिस्ट्रीहरू र त्यति पुरानो हिस्ट्री रिलेटेड इलिमेन्ट्सहरू मेटेरियलहरू तपाईँहरूले चाहिँ त्यति सजिलोसँग देख्न पाइरहेको हुँदैन कि. त्यो मेरो मेन एम थियो कि आजको टपिक.
भेरी ट्रु सर, भेरी ट्रु.
अनि फेरि कोइन्सिडेन्टली के भयो भने काजान युनिभर्सिटीको कुरा गर्नु पऱ्यो, लौ सेक्सको कुरा नगरिकन हुने भएन. काजान युनिभर्सिटी भनेपछि फेरि मेरो सुपरभाइजर त्यहीँबाट हुर्केर आएको. मलाई मौका पाएँ आफ्नो सुपरभाइजर फोटो मात्रै त्यहाँ देखाउनु पाएन, राखेको त्यो फोटो कहाँ गयो थाहा छैन.
एउटा क्वेसन सोधिहालौँ सर. अब रेगुलर खासमा चाहिँ मलाई दुईवटा एउटा अलि रिलेटेड एउटा अनरिलेटेड क्वेसन सोध्न मन लाग्यो सरलाई. पहिला चाहिँ अनरिलेटेड मतलब टक सेकेन्ड नट रिलेटेड. जस्तो म्याडमलाई चाहिँ धेरै ठाउँमा लिएर जानु कन्फरेन्समा लिएर जानु भएको छ. धेरै देश जहाँ जहाँ घुम्नु भएको छ त्यहाँ पुर्याउनु भएको छ म्याडमलाई चाहिँ खास कतिको इन्ट्रेस्ट छ म्याथमेटिक्समा, यो कुनै पनि तपाईँहरूले गर्ने टकमा तपाईँले पढ्ने कुराहरूमा
म्याडमलाई म्याथमेटिक्सको इन्ट्रेस्ट होइन, म्याथमेटिक्स इन्ट्रेस्ट ठुल्ठुलो म्याथमेटिक्सहरूलाई भेट्ने इन्ट्रेस्ट हो.
त्यही त होइन. फेरि धेरै सरहरू अब जस्तो विदेश भ्रमण त गर्नुहुन्छ, अब इन्क्लुडिङ माइसेल्फ. मेरो त सानसाना छन्, त्यही भएर आयो रिजन नट टु टेक माई वाइफ. तर सरले चाहिँ जहिले लिएर हिँड्नु भएको हुन्छ म्याडमलाई. हाम्रो चाहिँ प्राय यो मेल डोमिनेटेड सोसाइटीमा सम रिजन अलवेज देयर टु नट टु टेक वाइफ, तर सरले चाहिँ लिएर जानुहुन्छ अनि म्याडमको आफ्नै इन्ट्रेस्ट चाहिँ के छ भन्ने लागेको मलाई चाहिँ त्यो फोटोहरू देखिहाल्छ।
उसको माइक छैन, ऊ बोलेन, उसको लागि म बोलिदिन्छु। उसको इन्ट्रेस्ट के पनि हो मैले भने नि, उसको इन्ट्रेस्ट ठुल्ठुलो म्याथमेटिक्स भेट्न पाउँछ मसँग भनेर संसारमा हुने ठुल्ठुलो म्याथमेटिक्स कन्फरेन्स कसरी चाहिँ अर्गनाइज गर्छ र त्यो कसरी हुन्छ भन्ने चिज चाहिँ उसले मजासँग 2000 देखि अहिलेसम्म चाहिँ मसँग हेरिरहेको छ। स्टार्टेड विथ वर्ल्ड म्याथमेटिकल इयर 2000, अहिले कन्टिन्यू छ अहिलेसम्म।
तर आई डोन्ट नो हाउ भोकल म्याडम इज है, अब म्याडमले बोलेको सुनेको छैन मैले, तर इट लुक्स लाइक म्याडमको एक्सपिरियन्स नै चाहिँ हाम्रो धरा म्यामहरूको जुन चाहिँ ग्रुप छ ओनिम्समा चाहिँ एउटा एकदम राम्रो टक बन्न सक्छ कि जस्ट एक्सपिरियन्स ओन्ली।
यस, थ्याङ्क यू सर। यो चाहिँ इस्यु रेज गरेकोमा दीपक सरलाई धेरै धेरै धन्यवाद। मैले पनि त्यही सोचिरहेको, मलाई एकदम रोल मोडेल जस्तो लाग्छ कि म्याडम र सरको। सर जहिले पनि म्याडमलाई लिएर हिँड्नुहुन्छ। यो इस्यु चाहिँ राम्रो हो। लेट्स होप विल मेक सम प्रोग्राम।
त्यही त, अब सरले हेल्प गरिनै हाल्नुहुन्छ थाहा भएकै कुरा हो, तर म्याडमकै पर्सपेक्टिभ चाहिँ के रहेछ भन्ने त्यो जान्न मन लाग्यो।
यो चाहिँ अनरिलेटेड म्याटर, यो आज टपिकमा अनरिलेटेड क्वेसन के छ?
सरले रिलेटेडमा अलिक धेरैचोटि ल्याउनु खोज्नु भयो जस्तो लाग्यो है मलाई। रिलेटेड चाहिँ के भने जस्तो मैले सम रिजन त्यो मैले आफूले नभेट्या हो कि त्यसलाई डिफ्रेन्ट तरिकाले प्रेजेन्ट गरे हो कि ट्याक्सी क्याब जेमेट्रीको बारेमा खासै आए जस्तो लागेन नि। ट्याक्सी क्याब जेमेट्री
सबै गर्नु मलाई इन्ट्रेस्ट चाहिँ नि लोजेस्ट कि जे मेटर छ त्यहीँबाट लोजेस्टको सबै मेटर मसँग छ। लोजेस्ट बायोग्राफ भने र फेरि त्यससँग सम्बन्धित अघि भने काजा युनिभर्सिटी फेरि मेरो सुपरभाइजर पनि त्यही युनिभर्सिटीबाट ग्रो भएकोले अनि त्यसमा अलिक बढी फोकस गरेको।
आइसी होइन त्यही त, कस्तो ट्याक्सी क्याब जेमेट्री चाहिँ रिसेन्टली आफैले पनि भर्खर पढ्न सुरु गरेँ, इन्ट्रेस्टिङ लाग्छ कि मलाई चाहिँ। त्यो चाहिँ मतलब सरको लिस्टमा पनि देखिन क्या, अनि त्यो लिस्टमा नदेखिँदाखेरि चाहिँ किन
कम्प्लिट छ नि छैन।
आइसी तर यो जर्नी धेरै राम्रो लाग्यो। अरूभन्दा मलाई त्यो युक्लिडको सुरुको जुन 13 बुक्सहरूको सरको त्यो इनिसियल स्टार्टिङ पोइन्ट थियो, त्योबाट चाहिँ जस्तो हिस्ट्री सेट चाहिँ वास्तवमा त्यहीँबाटै भयो जस्तो लाग्छ। जेमेट्रीको चाहिँ 13 बुक्सहरू नै सरले पढ्नु भयो होला पक्कै।
सबै पढेको छैन, सबै कन्टेन्ट छैन, तर त्यो कभर पेज जम्मै जस्तो मगा खाइरहेको छ कि म्याथमेटिकले त्यो ठुक्कै चाहिँ राखेको छ। त्यो मैले त उहाँलाई यहाँ कलेक्ट गरिरहेको।
त्यही त, अनि फेरि रसियन बुक देख्न पाइयो सरको कलेक्सनमा। मलाई अर्को के जिज्ञासा लागेको थियो भने त्यो चाहिँ रसियाबाटै ल्याउनु भएको कि त्यो चाहिँ किन्नु भएको कि कसरी ल्याउनु?
म चाहिँ के गर्थेँ, स्टुडेन्ट हुँदाखेरि पनि किन टेक्स्टबुक मलाई किन्नु नपर्ने भए नोटबुक किन्थेँ र चाहिँ पोस्ट गरिहाल्थेँ। अनि पेडी गर्न जाँदाखेरि जतिवटा चाहिँ किताब चाहिँ मैले भेटाएँ युजफुल हुने खालको त्यो किताब चाहिँ मैले भने आई हेभ मोर देन 300 कलेक्सन इन माई लाइब्रेरी। 3-4 कुरा त मैले देखाइसकेको छु।
हस्, थ्याङ्क यू सर, मेरो त्यति नै होला।
ओके भद्रमान सर, अब आजलाई एन्डै गर्नु पर्ला होइन सर? मैले रेकर्डिङ पनि अफ गरेँ। सो